Yeah, thank you very much. And firstly, I just want to start by saying thank you very much to Perry and to Joe and the whole babies group, and most of all to everybody who's watching. I'm hoping that I can share a little bit of what I've learned in my time working with Golang. As I said, I don't consider myself a traditional programmer. I believe that all programming languages are tools to accomplish a particular task, well, in my world anyway. Um, and different tasks for, different tools for different tasks. For me, Golang has worked out very well for the tasks I'm trying to accomplish. And I'm thinking that maybe some other individuals in here can find similar use. Um, As a note today, I'm going to be using the Golang IDE in what I say here. Obviously, Golang and Goland are different things. Golang IDE is simply one of many IDEs. You could be using VS Code or do what I did for a long time and simply code it in Vim. I'd like to claim that I coded in Emacs, but well, not even I am that masochistic. So we're going to be using Golang, and the other reason for using Golang as an IDE in these training sessions is I'm going to show you certain things which are the reasons why I prefer to stick to an IDE these days. Different IDEs have different functionality, but all in all, um, yeah, you'll get the point as I go. So, Golang. Firstly, let's talk a little bit about Golang and, what it is. Golang is one of many languages, obviously. Now, Golang as a language is actually, I would call it a merge of three different language branches, being C on the one side, Pascal on the other, and then some features of another group of languages, which, if memory serves me correctly, was originally developed in-house at Bell Labs, but I don't think, I can't be 100% sure of that or the names of those languages. But they took the best components and they kind of merged them together. It's a compiled language. This is something that a lot of people get a little bit confused about. Um, is Golang a compiled language? Isn't it an interpreted language? And they get confused about this because you can do a Go run without compiling things. It is a compiled language. Um, it's fast, it's versatile, and it's very well designed when you're trying to do multiprocessing and threading. But let's talk a little bit now about actual Golang projects and how Golang organizes its code. I think is a good place to start. So in my IDE here, I'm hoping that everybody can see the IDE well. I'm just going to start a new project there. Now, Golang organizes all of its code into almost modules or projects. In this particular case, I'm going to start a project here called Go Babies in F-Drive Go Source Go Babies. And I'll explain a little bit about how the code is organized in its folders and directories shortly. But let's go ahead and create that. And now I've got this base project here. Now, the thing to note about Golang is that, as I've said, if you've got a library or you've got your main routine, etc., Golang works by packaging these things into directories and folders. So if I now want to create a sub project, and we're going to call this one over here, I'm actually going to create a directory for it. And in there, I can go and create a Go file. And this will make, call this hello world.go. Okay, so what you're seeing here is now the very base of a Go application. There's nothing in there other than the package name. That package name is incredibly important. All the files within a directory have to contain the same package name. If that package name happens to be main, that becomes a package that will compile to an executable. If it's anything else, it'll be compiled as a library. And that package name is also used, unless you alias it, to reference things once you import them into other projects. In this particular case, and I'll demonstrate a lot more about that later, but we're going to call this now package main. The next part of a Golang package, like any language, if you look at C, if you look at Python, any of them, they've all got their imports. No exception to Golang. And those are used to bring in extra commands. Now, one of the things to know about Golang is that a lot of its commands, similar to C, are coming from libraries that are actually part of Golang itself. Obviously, there are thousands of external libraries, but things like your print commands, etc., etc., are all going to come from imports, and you'll see that in a second. Let's write a basic program quickly, and then I'll take you through everything in that program. Okay, so if you now look at this, the first thing this did, as I started typing format.printf, because I've got a clever IDE, it inserted an import line. That format is the library that it is imported to use the printf command. And the printf command is obviously what I'm going to be using to print something. And this looks pretty similar to C in many ways. But if I wanted to import multiple libraries, I'd need to group them so that I can group them like that. And we'll talk about how Golang groups various things as we go as well, because it's not just imports that you can group this way. The other thing to know, just while I'm talking about these imports, is that if I didn't want to have to type fmt.printf every time, I can convert this, to a .import alias. And if I do that, I've removed the need to actually add the FMT extension on my libraries to every command that I'm doing. One note about that, if you've got libraries that have conflicting functions in them and you .import both of them, you're going to have a problem. So you need to be a little bit careful about that. And that's kind of the absolute base structure of creating a very, very basic Golang program. I'm going to remove this .import alias quickly just to avoid any confusion. This program now, the main function here is the function that basically everything stems from. So your main function in package main is the start of your top level of your code, effectively. And this sits there and it will print hello world, and you will see that if I go and run this, takes a second because I think it's still indexing. There we go. It printed hello world. Nice and simple, right? Now, at the moment, obviously, I've called one command within the main function. So I think that the next step that I want to talk about with regards to Golang, because this is absolutely fundamental to understanding, that the language is what's called a typecasted language. So like any other language, you have variables, you have constants, you have different types. Golang is very, very sensitive that your variables of a particular type cannot simply be assigned to another type, etc. And you'll see that as we go. But first, I want to talk about the basic types of variables that you will find within the Golang language. I also want to just check for those on the stream and in Zoom whether or not people have any questions up until this point so that I can address those before I continue. If I'm saying anything that's losing anyone at any point, please just stop me. The questions are being relayed from both Facebook and Zoom to me within WhatsApp. Thanks very much for Perry and Joe for that. Say that again. Okay. In okay, so Atul, the imports are importing from libraries on the local machine. So there are a bunch of libraries that are built into Golang, the math library, the format library. Well, there are loads and loads of them. Um, you can also import external libraries. Now, this goes back to what's called the Go path. In my particular case, I have Go path set to F drive Go, and then under that there will be a source directory, and under that there will be a whole bunch of directories that contain all my different libraries. At the same time, the Go's internal libraries are stored wherever Go is installed generally. And that'll also be in your Go path. I hope that answers that question. Okay, great stuff. So let's talk about types a little bit. Like any language, you've got various types. So in this particular case, when you declare a variable, you can declare it like this. For um, x equals 10. Nice and simple. Default on that is x is going to be an integer. If I were to do a UN16, sorry, second y, z, UN810, those are all completely different things. X will start off being an integer. An integer is not the same as a UN16, is not the same as a UN8. They're all numbers. They're different types of numbers. And if in my code, for example, I were to go a colon equals x plus y, you'll notice, at least I notice, I don't know how well it's showing up on the screen, that that's underlined, saying, hold on a sec, I can't do that. The reason being is that there are mismatched types. X and Y, you can't add a UN16 to an int or a UN8 to a UN16. Here you actually have to assert that the variables are of the same type. So for example, if I know that my X is an int and I tell it that my Y is an int, suddenly it'll be okay, not a problem. So you've got to keep that in mind in dealing with Golang. Another important thing, if you look at this code here, it's all entirely valid in many ways, but I've got an underline on my Z, I've got an underline there on the A, and it's telling me up here in my IDE that I have errors. Here's the thing about Golang. It enforces, in some ways, a level of cleanliness to your code. You cannot have a variable declared that is never used. You can have a function declared that's never used. You can have a type declared that's never used, but you can't have a variable. It will tell me if I try and run this now, um, declared but not used will not compile. So if you've got something in your code that's declared as a variable here, you've got to actually use it. If I were to suddenly tell it to print x is %d, y is %d, z is %d, x, y, z, and then add in here suddenly I've got no errors because I've actually made use of those variables. Does that make sense to everybody? Everybody clear on that? I'm going to assume so, since I'm not getting any questions back on this. So that, now with regards to, we'll go back to what I was saying about variable types. Sorry, or int x equals to, I can never, I've been working with C for a bit, so excuse me if I'm a little bit, C and Golang tend to declare their variables and types back to front. So in what's in C and what's in Golang tend to be reversed here. But I can also declare a variable if I do it something like that, var x int. Now, with var x int, I've declared a variable called x. I've assigned nothing to it. So there it is. It's just there. It's an integer. Again, with types, I'll list all of the kind of important ones here, all the ones that I use most often. String. We'll talk about the latter. We'll talk about each of these in a little bit. Okay, so these are the basic variable types, and there are a lot of them because we'll talk about structures and all the rest as we go. But your most common ones that you're going to be using at the beginning are going to be strings. You're going to be using integers. You may be using floating point numbers. When you start getting into float 32s, UN32s, UN16s, UN8s, you'll use those if you're writing kind of optimized code or doing specific things that require smaller numbers. But again, please keep in mind, and I keep stressing this, that Golang is a typecasted language. So you cannot, for example, where you have F here that is a string, suddenly say that it's going to be equal to an integer because it's not going to know what to do with it because they are different types. Same way that you can't take an integer straight into a float, you actually have to do some assertions. That's a major difference to what a lot of Python programmers see. And I know that a lot of Python programmers really struggle with that typecasting at first, and it causes much swearing. Personally, I like it because it keeps my code far more precise. Any questions on this before I start talking about how we use these variables, etc., in functions and in other things? Well, we all clear. Okay. Okay. So in G and H, I'm going to talk about those in a bit. That's not an array, it's a slice. And there is a big difference between an array and a slice. Let's add, that is an array. So an array in Golang terms is a static size. It cannot be changed. You can add data into it, but you can't change the size on the fly, etc. It is a static sized grouping of a specific element, whereas a slice is a different thing. A slice is an array that is almost dynamically sized, but they do have certain fairly different properties in working with them as you code. So for example, if you look at var g here, which is a slice of bytes, which is a grouping of bytes, versus var h, which is a grouping of UN32s, versus I, which is an array of bytes. I is always going to be 4 bytes within that grouping. G, however, and H at that point are 0 length slices, which means that at the moment I haven't actually allocated any memory to put anything into them. And if I were to try and put something into them at the moment, so I were to do something like G0 equals 1, which will put 1 into the first byte, it's probably going to allow me to compile this. I just want to remove some of the other code here. Let me just comment out some of this here so that, again, remember these variables are declared, but they're not used. The net result of that is I have to comment them, else I'm never going to be able to compile anything. And we'll just comment that out as well. So we've got something here called G, which is a slice of bytes, and I'm now going to try and put something into it. Watch. If I run that, index out of range, there is no space in there to allow me to put anything into it. If, however, I were to allocate some memory for it, so G equals make byte 10, now I've got a 10 byte space, a grouping of 10 bytes that I can put things into, so I could fill G0, G1, G2, G3, etc., and it'll work just fine. Now, the question with regards to typecast, sorry, I did just see that question. Typecasting means that a variable is a specific type. You can't use one type as another type, if that makes sense. I'm trying to find an easier way to explain that, but I think you'll catch it as we move along. But effectively, data in Golang is assigned a specific type, and that type is what that data is expected to be. Types are not, you can't add types together, etc. They are different data. With regards to the question as to why someone should use slices, because slices are dynamic. You can grow them, you can shrink them, and you can do all sorts of other fancy tricks with regards to slices, and I'll explain more about that in a bit. An array and a slice, everything within there, yes, holds the same data type. There is another data type which allows you to get around that, but I'm not going to go there yet because I think we need to cover some more elementary aspects of the language before I go into what are called interfaces, but we will get there. And it's, yeah, let's get there in a bit. But for now, yes, slices contain all the same data types. Now, let's talk a little bit about what happens when we attempt to use. Okay, now the other question that I've just seen coming in from Facebook is with regards to how I've handled my variables. So if you look at var x int like that, that's declaring an empty variable. I haven't put anything into it. Whereas if I comment that one out and I do x colon equals int 10, that's creating x with a value of 10 in it. Now, Golang's a little smart here. So if it's a number, right, x equals colon equals 10, that by default is an integer unless I specify otherwise. In the same way, that will declare y, I believe, as a float 64. If I were to do z colon equals abc, z is automatically a string. And so you can play a little bit there without having to declare var x whatever type and stick with the default types, but you do lose some flexibility there, and there are reasons to use the other variable types outside of that default as well. But essentially, for the purposes of starting off, if you do var x int over there and do x equals 10, that says declare x as an integer, and then x equals 10 means put 10 into that variable. That there is identical to saying that for the purposes of learning. There are some differences on the back end, but for now, you can consider those pretty much identical. One note, let's talk about what's called scoping. Variables within Golang are very constricted to the scope in which they were created, being the function or the subroutine in which they were created. What I mean by that is that if I have something like var x int, and I were to do something like, just trying to think of a good example of this. Um, x equals 2, and then I, over here, what I've just written there is actually really, really bad coding practice, but it highlights a point. X over here, as defined at the top of main, is local to the main function. And interestingly enough, if I were to use that inside the for loop here, it would be equal to 2. However, this x over here, x colon equals 1, right, is actually declaring an entirely new instance of x inside the for loop, if I remember correctly. Because effectively what is happening inside here has got a completely different scope. You've got to be careful of this, because if I were to do something like this, that there, okay, so for loops are, I just want to verify this. Yeah, you'll see here that this print statement, right, can't actually see what y is, because y was declared inside the for loop. Y's got a different scope, so it's not available. However, x over here, which was declared above the for loop, is available inside the for loop, but you can also redeclare a new x inside the for loop, which won't be available, and then it'll use the outside one. That sounds confusing, I realize that. So let me stop for a second and take questions on that before I continue. Does everybody understand scoping, and when I refer to scoping, what that means? Questions, anybody? Or have I completely lost everybody? Yeah, okay, cool. So then let me continue. But effectively, that's something else to really remember inside Golang. And scoping is incredibly tight. So a for loop, even in an if statement, right? If you, in certain cases, and I'll show you examples as we go, you can have things inside an if statement that aren't available outside of the if statement. because of the localized scopings. Data is kept very, very localized. But that's a little bit about variables, what I meant by typecasting, that talks a little bit about scoping, etc. Now, as with any language, a language is based in terms of its variables, its constants, its functions, which are divided routines. You've also got, in the object-oriented world, you've got objects and they will have various methods associated with them. We will get to that, and Golang is not a typical object-oriented language, but it does have similar concepts on that, which we'll talk about. But I first want to talk about constant. We've talked about variables. We've also have these things called constants. So this is a constant equals 10. This constant here, right? Let me just delete that over there. You'll see that it's in italics. It's got a soft error in it because a constant, I can compile that without ever using it because it's a constant, but I can't change it. So a constant is simply data that is locked. Again, these are typecasted. So that there will be an integer constant of 10. I can print it, I can use it as a reference to things, but I can't ever change it, and it's an integer forevermore. I did just see one comment that came directly to me on WhatsApp that some people saying that they can't comment on the Facebook link. If you can't comment on the Facebook link, it's either because you haven't joined the group or alternatively, you're not properly logged into Facebook. The other question that I saw was about the variable types again. Another question about going over those variable types. So let me do that really quickly and step back a second. An integer is a whole number, no decimal point, etc. And on a modern 64-bit machine, which most of you will be using, will be 64 bits long, which means that it's a really large number. 2 to the 64, whatever that number is, I'd have to work it out. Well, actually, we can see what that is. So to demonstrate the difference between the variable types, we will go ignore the syntax here because I'm just filling in the full length of the number. 1, 2, 3, 4, 5, 6, 7, 8. Is a UN64. B is an int of, actually we can just take out that and. B is an int of the same thing. 1, 2, I think I've got that right. C is a UN32, and you'll see when I actually print these what the difference is. Let me just make sure. The reason that I'm just using hexadecimal notation here is that it's just easier than trying to remember what the actual decimal numbers are. So if I were to now print these in normal decimal format, UN64 and int %d and UN32 %d ABC, and we run. And interestingly enough, int is signed, so I can't actually take it this big. So an int is actually slightly smaller than that. I think if I set that as F0, It's also still too big. I can't remember exactly the size of an integer, but an integer is basically a smaller number. So if I take that out, got to take that out as well. And take this out. There we go. Let's take all of this out. Come back to that. Where did I make a typo somewhere? Ah, there we go. That's your difference. Your UN64 is a much bigger number than a UN32. A UN32 typically runs to about 4.2 billion, 2 to the 32. An integer is a signed version of a UN64, so slightly smaller than the UN64, because you've got your signed bit in there, which means that it can be positive or negative. Anything that says U in front of it is unsigned. It's always going to be greater than 0 or greater than 0. Floats are numbers with decimal points, again, can be positive and negative. Strings are obviously strings of characters. Byte types, single character or single number that can range from 0 to 255. That makes sense to everybody. Sorry for the diversion to go back. I just saw that question. Wanted to make sure everybody understood this. Yes. Okay, so I just got a question that I saw in the Zoom chat that says, does scoping mean that a variable is valid only within the scope function or subfunction that it's defined in? Yes, that's exactly what it means. Unless you pass data in and out of the function, it's only going to be valid within that particular scope or with where it is defined. You can define global variables. Generally, you don't want to do that. It's not good practice to do it. And I'll explain a little bit about passing things around in a second and how that works. Let's do that. So as I said to you, we talk about functions in any language. So you've got your function main, you've got whatever other functions. That's critical to any language because it's how you group your code, right? So in Golang, a typical function, this is X. Okay, so now I have a function. Let me make this just look nice. We have a function, I've called it print this, and it takes an argument called X. And it's going to print that argument, and it's going to be 10 because that's what I'm passing into the functions. I've just seen another question, which I'm going to come back to in a second about memory leakage and different variable types. I will come back to that. So this here, we've got this function. It takes this argument called X, and it's going to print it, right? This is fairly simple. If I run it, you'll see that it's printed. This is 10. Right. Now, this is where we start getting a little bit interesting with regards to scoping and variable types. So firstly, remember what I said about variable types and Golang being very specific as to the type. If I were to do this, that there, where X is a UN32 with a value of 20, I cannot pass X into that print this function because print this is expecting an integer. It's not expecting a UN32. And so it's going, whoa, this is the wrong variable type. And even though it's a number, it's strict to this. I could, however, tell it to assert that X was an integer, and that will work fine. Now, we're going to talk about, okay, so that's the other thing about case sensitivity, right? Two totally different variables. Variables in Golang are case sensitive, functions are case sensitive. So with a capital X and a lowercase x, totally different variables, totally different types, right? So yes, the language is case sensitive. There were also certain other caveats about the case sensitivity in the language with regards to packages, and I'll talk about that in a second when I actually demonstrate that, because you have this thing where you're building, remember we're working in package main here, as I said, that's kind of your main routine, and everything else is imported into libraries, from libraries. Only functions whose names start with a capital letter are exported out of the library. So you cannot call a function from an imported library if the function is defined with a lowercase letter. And I'll demonstrate that later. But effectively, if you're defining a function and your name starts with a lowercase letter, you will only be able to use it within that particular module. You won't be able to export it as a library. And that's quite important to remember. And I've seen that trip up a lot of people. There are good reasons for it because it allows you to create functions in your libraries which are used inside the library, but you don't necessarily want to expose on a wider basis. Does that make sense to everybody? But yes, effectively that is very similar to it's similar to that. Yes. Um, it goes a little bit further than that though, because when you start looking at declaring things like structures, etc., which we will get to as we go, um, a structure's elements that are uppercased are exported. If they're lowercase, they're not exported. They become private elements of the structure. But I'll show you all of that as we go. Um, but let's first go back to where I was here talking about variables and scoping. If you look at, we'll just take this back to var x equals int 10, and so I'm passing an integer into this print this function, and I'm printing it out. And the variable name here is called x. I'm also taking x as an input. If, however, in here, x equals 20 and I print it, and then I print x like that. What's going to happen here when I run this? Anybody care to take a guess? Okay, well, let me tell you what's going to happen, right? X over here is declared as part of main. Over here, X is a completely different variable. When I said X is 20, I am not affecting the input here. So what's going to happen is this is going to print 10. I'm sorry, this is going to print 20. This is going to print 10 still because I haven't changed the variable at the higher level scope. And you'll see that here. Um, where have I got okay, yeah, that's fine. This is 20, which is what it's printing from over there. And the X in the main function is 10. Now, that's because, as I said, what I passed in here and this variable are completely unrelated. Obviously, there are ways of passing data into a function in such a way as to be able to modify them before the function returns, and we'll get to that. It goes into pointers. But before we do that, we're talking about functions at the moment, and you'll notice that that function there doesn't actually return anything at the moment. So let's say I now wanted to return x, and I were to do something like that. First thing you'll notice is that it's got errors and I can't compile it. One of the things about Golang, your functions will only return what they're told to return. So if I change this definition slightly and I tell it this function is going to return an integer, that there is now valid code. And what happens here is I'm passing 10 in there. I set the local variable x to 20. I return it and I put it into my x in the main function. Now I'm going to be printing 20 and 20. 20 and 20. But the same way, if I were to rename this to y, all of that is local to the function, but y is going to return, and I'm going to put it into x. It's still going to print 20 and 20. Does that make sense to everybody? Any questions, Facebook or otherwise? Yes, you can't. You can't. A constant is a constant is a constant. Um, we'll talk a little bit about pointers and the rest going forward, but no, a constant is a constant is a constant, which is a good thing because there's a reason why it's called a constant. You know, if you're going to be changing your constants, you probably shouldn't have them as constants. Um, because I'm prone to breaking rules, I will also say, however, that there are ways you can do some of the stranger things, but let's give it a few weeks until I get you guys to the point where I don't confuse you when I start showing you how to break almost every rule that Golang has. Because there are ways to do it, but you don't do it unless you know what you're doing and you've got a good reason to do it. Let me say that. Now, with regards to, we were talking about functions here. If you want multiple inputs on a function, this is quite simple. If I were to do ABC and change this to ABC, and we are going to just return 0 and change this to 10, 20, 30. And you'll also notice, just one note here, it's a good thing I actually remembered to say this. You'll see here that x equals print this. That is very different to typing x colon equals. In x colon equals, I am declaring a new variable. X equals sets a variable. So if I had, that is valid because x is declared over here, it's set over here. That is not valid because I'm now declaring two versions of x in the same function. So that's why I needed that colon over there. So what does this do? This says into this function, I'm passing 3 bits of data, 10, 20, 30. I'm returning 0. X will return as 0, and this will print as 0. If I wanted to expand this with different types, B is a string, E is a another int. This function call here is invalid at the moment. The reason that it's invalid, I don't pass it enough arguments. If I were to pass it like that, that's valid. I'm now passing it the same arguments. Arguments have to be in order. They can be in different types, obviously, separated as I've shown over there. You also have ways of declaring variadic arguments that I will go into at some point in a further session, where you can effectively pass a variable number of the same type of argument. But we'll get to variadics once I've covered slices, because it's quite important to understand the slices before we get to the variables. Now, you'll remember earlier when I showed that if I pass a variable like x into a function and I change it and I return it, what I'm actually returning is something very different to what I was passed in, because they're two totally different variables. There are certain exceptions to this, and I want to talk quickly about slices. So, if you'll remember earlier, I showed you guys something like a byte. That declares a slice of bytes that has no data in it, right? I can put a number of different bits of data. I could also, by the way, declare that like this. In which case I've declared a slice of bytes that contains 1, 2, 3, 4, 5, 6, 7. And if I print that slice, by the way, you'll see that in this particular case, I'm using the percentage V operator for the print. That's purely because that allows Golang to determine what it wants to do with the data that's passed in there. It's a whereas a percentage D will print an integer, a percentage F is a float, S is a string, etc. So those are just the different print operators. They pretty much mirror what's in C. If anybody wants to contact me offline, I can give you a full list of the print operators and examples of all of them, but there are a whole bunch of them. When I run this, you'll see that effectively I have a slice or an array going from 1 to 7, right? Here's the thing. If I were to do something like this, that there will add something to that slice. So now if I were to run this, I've got that extra 8. And that's the difference, one of the main differences between a slice and an array. A slice is variable. It can change size. And you can add things. You can also start removing things from a slice. So if I do something like that, that effectively is going to say that A must now start from element number 2. So 0, 1, 2, A is going to start at 3, and if you run it, A has suddenly been shortened. So you can slice it. And that's obviously in an assignment, but you can also print something like that. If I were to do something like, let's take that out. Something like that, where A is now printing just bytes 2, 3, 4, and 5. Notice that 5 isn't included in that print, by the way. It'll print elements 2, 3, 4 on that. So slices allow you to reference sub-elements, etc. With regards to the question on is append a public function, append is part of the base language. You don't need an import library for append. It's actually part of the base language. Now, the other important thing to remember, so I can append over here to grow a slice. What I can't, however, do is keep in mind there are, I'm actually just going to number this from 0 just to make this easier, because remember all slices are 0 offset in Golang, so 0 is still a valid byte, so we'll just align this nicely so that I know 0, 1, 2, 3, 4 when I reference it. I can append 8. Now I'm going to have a slice that contains 0 to 8. If I were to do that, it's invalid because that says assign to slice point 9. Slice point 9 doesn't exist yet. Append allows you to add. Once I've added, I can change what's in that slice point. So if I were to do A8 equals 9, that is entirely valid because the actual point within the slice exists. So it has to exist. In the same way, and this is really, really important, if I were to do B equals make by 10, that is going to make me a slice that's filled with zeros, but it's going to have 10 elements, 0 through 9. That allocates memory. So B1 equals 1, B2 equals 2. Those are all entirely valid things that you can do. But this make over here cannot be used to extend a slice because it'll override it. If you look at, let's take out this B, I'll show you what I mean by that. If I were to print A at the moment, just check. What am I missing here? 8 equals 9. Ah, there we go. Run. There we go. You'll see that that A8 did change that byte to 9 and it works fine. But now watch. In there, I've got effectively 9 bytes, 0 through to 8 will I be numbered 9. If I were to do E equals make byte 9 and then print, suddenly it's all 0 be careful with make. Make will basically reallocate the entire slice, and you will use your data in it. So you use it for allocating memory. You can also use it for cleaning up memory. If you do that, you clean up your slice rather nicely. That makes sense to everybody? Any questions? You use make when you first declare a variable, or potentially where you want to clean up memory. So if, for example, I'm trying to think of kind of simple examples of this. If you were to do something like this, so in this case, I've declared make. I've declared A, and it's a slice of bytes. It's got no elements in it, right? I is less, sorry, it's less than 10. Oh, this is something also that's quite important, which I will show you in a second. Sorry. That right there, firstly, there are a number of problems with what I've just written. Number one, A has a 0 length, so I'm going to end up effectively overrunning my slice. If I change A over here to say that it's got 10 elements, I'll be able to fill that in rather nicely. However, I've still got an error there. You'll see here that it won't let me assign it because A is a slice of bytes. I, in the for loop, because I is being instantiated as a variable and I am not explicitly specifying its type, is an integer. That's a slice of bytes. You can't put an integer into a byte. So if you wanted to do that, that would be valid. Does that make sense to everybody? Questions on that? Before we get, let's just have a look. Okay. Um, okay, so append is for appending. Deleting, I'm trying to think of the best way to put this, because there isn't a specific word for deleting inside a slice. There is in what's called a map variable, and I'll talk about maps in a little bit. But yes, append allows you to effectively grow a slice. If you want to remove it, right, so make can be used to delete everything inside a slice. It can be used to nullify everything in a slice while keeping it the same size, right? So if you look at this piece of code over here, that prints 0 through 9, so we have our 10 numbers in our slice. If I were to do that, that's going to say replace the entire slice with a new slice of 5 bytes of all zeros. So that's going to replace the slice and it's going to make it smaller. This other slice is just going to disappear. You'll see this here. It's all gone. So make is used to basically remake the entire slice at whatever length. Anything that was in there is going to disappear. If, however, I wanted to delete something out of a slice, there are various ways to do this, right? If it's at the front of the slice, and I do that, you'll see that I've just chopped off 0 and 1, which are the first two elements of the slice, by effectively telling it that this slice now only starts from element 2. And I've replaced A with itself, except minus the front 2 bytes. If I wanted to do that at the end of the slice, um, can you hear me now? Okay. Sorry about that. So if you look at the first one, which I wrote there, I'll just repeat that. That says A is now equal to itself, but starting from the second element within the slice. This top one, which I've just pointed here, so len in Golang is length. So what's this say? It says A is equal to A, but only going to the length of A minus 2 bytes. Because remember, if I've got a slice that says A0 at element 0 and I make that equal to 1, I have a length on my slice of 1, not 0, because A0 is still part of the length. So your actual offset is always length minus 1 for your last element of the slice. In this case, I've said A is equal to A, but end it at the length of A minus 2, and that's going to chop off the last byte of the slice, if that makes sense. So that's how you chop off the front of the slice. This is how you chop off the back end of the slice. And if I run this, you'll see what I mean. You'll see that now my slice is missing 0 and 1, which got taken off over there. It's also missing 8 and 9, 8 and 9, which are being chopped off over there. If I were to do that, it's chopped off just the last element. Because remember what I said earlier as well, the last element that you refer to here is not going to be included in the slice. It's the end point. It's not actually included. Which is why you see length of A is going to be 10 there, but position 9, which will be because of the 0 offset, and then it's not actually included in there, which is why you can do len minus 1 to chop off the end of the slice. Does that make sense to everybody? I know when I sounded that, sometimes I even confuse myself here. Yes, len minus 2 means to chop off the last 2 bytes. But note the colon there, right? Because the colon here says if you've got a number colon, you're referring to act on the stuff to the left of the colon. And that's what you're acting on, and the rest is remaining. Colon len says keep everything before the colon, but only up to that point. So if you were to do this, actually, let me print this over here. So if you were to print that, and I've got no colon there, right? The reason that I can't assign this, by the way, and you'll see why in a second. what I'm doing in this print statement is I'm printing not the slice, but a byte, because I'm printing a single element. That colon allows you to say that you're still working within the context of the slice with multiple bytes, whereas the len statement as it sits in that definition of the print will only print one byte, and it's going to print the last byte. You'll see it prints 8, which is the last byte after I chopped off the byte over here. That makes sense. Okay, so copy a colon minus 2. That's very Pythonic notation. Um, I actually can't remember. I don't think, no, you can't do that in, um, in Golang. You actually have to specify a len over there. Um, So I just had a question on the Zoom channel for those on the Facebook channel that says, does this work something like a square bracket colon neg 2 close square bracket? The answer is you can't do that. You actually have to put a proper number in here because you have to go, you're going to a particular point, if that makes sense. So that will work like that, but if you just put neg 1, it won't. Everybody kind of clear so far on this? Braith, what you've just asked about with regards to slices, by the way, on what you wrote about the back-end array on slices. I will get to that in future sessions, but if you want to know about that earlier than the future sessions, let me know, because that gets quite complicated and it goes into how Golang actually organizes things in the back end. What I will say to all you guys, just to address a question that I saw on Facebook um, about slices and arrays having a back-end array, that the slice doesn't point to back-end data directly and is actually a structure that is actually correct. Effectively, if you look at strings, if you look at slices, etc., all of those are effectively different forms of structures that are largely invisible to the user but can be made visible in the fact that the compiler is interpreting a structure which is telling it about what is underlying on the slice, but is normally invisible to you. There are ways to access it, but I can talk about that in a future session because it gets quite complicated. I think, you know, I think for now, what I want to do is I want to leave it here for today, right? Because I need people to kind of get hold of Go, play with some of the stuff that I've taught you. There is a ton of reading material out there. I'm available on the babies group, and Joe can talk about how you can join the babies WhatsApp group. I'm available on Facebook, and I can, answer questions that have come in, and as best as I can and as much time as I can, I will attempt to help you and guide you. But what I would say is the stuff that I've taught to you about today that is in this video, go and play with it, experiment with it. And when we come back, I'll be doing another session like this same time next week. I think, Joe, we'll take this a step further. But if I go much further than this, I think that without giving you the chance to revise and play with what I've told you, I may end up losing you guys. And I'll say another thing about as you learn any language, the more you play with it, the more it will embed itself in you. If you take a language and you don't play with it and experiment with it and use it, you will forget it. So I think let's possibly, I just had another question, by the way, with regards to the slice. So let me answer this first before we close. Yeah, no, I'll read out the question. I'm reading the question myself and trying to figure out in my head how to answer it. So the question was, so if we want to delete, so let's say the fifth element of the slice, then we need to take slice from 0 position to fourth position and from the sixth position to the end position and then concat them. Yes, that is effectively right. And I'll show you how you would do this actually, because it depends on whether or not you want an ordered slice or whether or not the ordering of the elements in the slice isn't important. So let me show you something here. If we print A right now, so keep this really, really basic. We have a slice, 0 to 9, which is 10 elements. If I wanted to now remove position byte 4, which will be position 5, and I do not care about the ordering of my slice, I could do something to this effect. 0 to, I just need to, so I've got to wrap my head around this again. A minus 1 equals A minus 5. Equals A. So that looks really complicated, but it's not actually. What I effectively did there is actually one of the more efficient ways of removing something in the middle of a slice. What it's doing is it's effectively saying that it must swap the fifth byte with the last byte, and then it chops off the last byte of the slice in the second line. So if you look at this, it says make A5 equal to the last byte in the slice. Make the last byte of the slice equal to A5. So there's the swap, right? Then A is now A minus the last element because you've just done the swap. And suddenly you've removed that element, but you've also completely removed any ordering on your slice. The other way to do that would be something to this effect. I'm just trying to remember the exact syntax for this. If I were to do a 0 to 5, and sorry, declare a new one, and then b equals append b comma a6 colon. That dot 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 is effectively expanding the slice to bytes because append only does one at a time, but that dot 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 allows me to expand a slice. I'll end up with B with the element removed in the order. So there are ways and means of doing this, but to answer the question that I had there about removing a middle element, the ways and the methods that you do that depend on whether or not the ordering of the slice means anything to you. With regards to the question that I've just seen on the chat about Golang and is there a freeware edition available? There's a 30-day trial. After that, unfortunately, you do have to pay for it. In my book, it's well worth it. I can't remember exactly what it costs, but it wasn't a huge amount. Otherwise, there is VS Code, etc. I haven't used VS Code enough to comment on whether it's better or worse. I think other people possibly could. What I can tell you is that Goland as a product is fantastic and I'd recommend it to anybody. So I can't comment on the other things, but I can comment on Goland, and I'd say that Goland, for me, is probably one of the best IDEs I've ever touched in any language. There we go. Somebody said it's about $9 a month. Not going to break the bank here for anybody. Yeah, exactly. So you know, yeah, just remember, I am hoping that next week we see more people, not less. I'm going to be very unhappy if half of you guys never come back. Wow. So, firstly, let me explain a little bit about what I do in my daily life. Well, I'll explain parts of it, and I know that there are colleagues of mine sitting listening to this, so I have to be careful what I say here. um, a lot of my job is about network R&D, which means that I write a lot of low-level code that interacts with the network. Um, that includes writing extensions to protocols like BGP, other network functions. Um, I write a lot of code that is related to collection of network data and analytics thereof. So very high speed data point input pipelines, which we then analyze with Golang code. Um, there is code that we write that's doing stuff like live packet analysis to detect attack traffic, etc., etc. So effectively, I write really, really, really low-level code normally for a variety of functions and for a lot of R&D purposes. I've also written a fair number of APIs because Golang has a fantastic method of writing APIs that I will share with you guys in time. Um, and in fact, one of the reasons that I really liked Golang was because I could move away from Flask. Sorry to the Python defenders, but it was just so much better when I went the Golang way on that particular point. Um, and yeah, so Golang for me is used for a variety of things. Nowadays, even if I want to do a basic script to process things where I've got a text file with 100,000 entries in it and I need to isolate and add things together, for me, it's so much quicker to throw a 10-line Golang piece of code at it than to do it in anything else. So Golang for me is very general purpose. Hope that answers that question. Okay, so it's a fascinating question, and I'm going to answer it in this way. Terraform, influx time sequence database, Docker, um, Telegraph, all of them are written in Golang. That tells me firstly that Golang not going nowhere, right? Secondly, unless the US Department of Justice has their way and manages to break Google up into a million bits, which would be insane, Google's behind Golang. I don't see Golang going anywhere. You are seeing, yeah, you're seeing various bits and pieces where you're starting to see more and more Golang in certain parts of Azure, where I've seen various Golang libraries and bits and pieces there. You're seeing it very heavily with inside Google, obviously. Um, and in fact, Google actually has an internal Google choir. And if you go and search on YouTube, they've sung songs about Golang. And if you're singing songs about the language that you came up with, you're probably not going to let it go anytime soon. So I do see a very bright future for Golang. One of the things I will say that I really like about Golang is that they make a commitment that as they develop the language, they make sure that it's backward compatible. So a new version of Golang is not going to be like going from Python 2 to Python 3 and everything blows up in your face. Um, they do keep feature parity very nicely there. And I think that'll also help it last. Obviously, languages come and go. You can never be sure. Um, for some bizarre reason, people 10, 15 years ago believed that Perl would be around forever. Um, it's still around, but not very much. Thank God for that. Sorry, oops, did I say that? I'm not a fan. But yeah, I see a bright future for Golang. I really do. As for Gopi, your question about is Golang good for IoT? My friend, what is good for IoT is going to depend on what you're doing with the IoT. You know, being good for any particular function is going to be how you apply it and what is the particular device. If you're, for example, writing a server that a lot of IoT devices are going to be communicating to and collecting data on it, yeah, Golang will fit that purpose rather nicely. If your IoT device is running a microprocessor that is going to require assembly language to write down at the machine code level because it's not normally PC compatible, then no, Golang's probably the wrong choice. So it depends. The other question that I've just seen is, can I recommend a good book for Golang? There is a book called The Go Programming Language. Um, and one of the guys behind it is one of the guys who wrote what is called the K&R book in the C world, otherwise known as the C programming language by Kernighan and Ritchie. Um, the Go programming language is probably the best Go book I've seen out there. In the same way, the C programming language is the Bible to learning C. So yeah, that that works as well. And then what I'm also going to do is after these sessions, and I'll post the link both in the WhatsApp group and on the Facebook channel, is I'm going to set up a GitHub repo that's got a couple of bits of code in it that covers some of the stuff that we've done here. You can go and check out that repo so you've got examples of that code. There's also a site called play.golang.org where you can type live code into the web browser and then play with it. And you'll be able to copy my GitHub repo bits and pieces into there if you want to play with them. I will try and get a permanent play repository up locally where the code won't ever disappear. I unfortunately didn't get to that today, but as soon as I do, I'll post that into both the WhatsApp group and the Facebook group as well. And unfortunately, unfortunately, for Joe over there, Facebook's also recording it and it's free there. Now, I just want to say that, that's really important to anybody in here, is that you can sit in classes, you can read books, you can whatever. But if you really want to learn a language, the only real way to learn it is to sit and play with it. Take what you hear on this, use it to play, experiment. One of the other things I would say that in learning any language is that one of the things that I do is always set myself a task, which I do not know how to do when I set it, and it's deliberately that way. And I keep trying until I know how to do it, unless it turns out to be impossible, which occasionally, you know. But set yourself a something that you want to accomplish with the language. Make sure that it's something that you cannot do when you set it, and keep trying until you can. Go and Google, research, etc., etc. That forces you to keep learning. It's a good way to learn coding. And just by the way, we will also be comparing your code to Joe's code to make sure that he actually writes this in better code than you. So that challenge is binding on him as well. Are there any questions from the Facebook group, if I may ask? Any comments from there? You can just type them into the chat. Oh, Oh, no, that's perfect. Well, that was my problem with that question because I was sitting there thinking, I'm not sure that I know how to do that. Anyway, guys, thanks so much, and we'll see you at 2 o'clock next week. I hope you guys enjoyed it. As I said, on the WhatsApp group, on the Facebook channel, I'll be monitoring both. I'll help where I can. If I do take a little while to answer questions or whatever, it's not because I'm ignoring anyone, it's just about time. But I do try and answer as much as I can. I also will say that particularly within the WhatsApp group, it's always best if you post your questions publicly in the group rather than directly to me, because that way everybody benefits from the answer. And by the way, there are no stupid questions. Anyway, guys, thanks so much. Like I said, I hope to see you all next week, and bring your friends. Cool. Great stuff. Cheers, guys. Thanks. Bye.